Okay, let us see this next example. Find the center of gravity of the uniform laminar below from sides AB and AE and AB. So this is our AB, this is our AE. We say the first thing, we get the area of these two. So I'm going to get the area of this, which is A1. I also get the area of this, which is A2. So this implies that if I get the areas, of course, area A1 is going to be, this is a rectangle, so I get the length times width, which is going to give me 80 meters squared. So now, because we want the center of gravity, now I'm going to calculate it to be, that will be the weight by unit mass. Why? Because I want to get the weight now of this laminar. It means that I will get the area times the weight by unit area, so that I can get the weight. So my weight 1 is going to be now the 80, then times the weight, the area of this times the weight by unit area, which I'm saying it is W. Then when I come to getting the area A2, when I come to getting area A2, now this one is a triangle. So now that its area is given by a half times the base. The base, you see from here is the base, which is the same as this 8, then times the height, which is 12. This is going to give us our area 2 as our area 2 as 48 meters squared. So it means that now my second weight, I'll get the area times the weight per unit area using this formula here. After getting that, so that our interest is in getting now the total. Now, if I get the area of this and the area of this, and I get their weight per unit area, weight per unit area, not per unit mass, weight per unit area. Weight per unit area, as simple as that. So now I get the total weight, which is going to be, I add these two, 80 plus 48, which is going to give me 128 W. And this is the total weight by unit area. So the whole laminar now has this weight. So because our center of gravity is going to be at X bar, so we are going to use our formula which says X bar, Y bar is going to be equal to the sum of Wi of, because now we want the Xi, Yi, we want the coordinates. They are giving us two axes. That's why now I have also two coordinates. If they give you one axis, then you use one coordinate also. So Wi. Now this is the center of gravity. Now, when you look at this laminar, you see that it has a line of symmetry. So now, if I sketch it here, we are going to use this idea here, as I'm going to show you. So if I sketch it here, this is the case I'm having. So this is our height, which is 12 units. So A, B, C, D, E. Now, it means that now, this formula here, we have the weights, but you know that the weights of these two lamina, they are acting where the center of gravity, their center of gravity is. And this formula, we have the weights, but with their coordinates. So what we do, we get the coordinates. So of course, this is a rectangle. It's going to act in the middle, so let me call this one B1. And this one, for that of a triangle, we say it's acting there at our B2. Now, the coordinates for rectangle, It means that now they gave me this as 10 meters and they gave me this as 8 meters. So it means that if this one is acting in the middle from AE and AB, so from AE, it's going to give me now my horizontal coordinate for the D1. So from AE, from here, decide this distance from AE. If this is 10, this one is going to be 5 because it's a half. Because we said for the center of gravity over the rectangular is acting in the middle, that's why I get a half of this. Then from AB, you see from here, I'll be getting the y coordinate for this, which is going to be 4. And here, we are having weight 1 acting there. Then, of course, you see this one is going to be my line of symmetry acting in that order. So if you saw now this one, the line of symmetry, it covers this part and this part. So here, I can able, because I have two axes, it means that even the center of gravity for the wall is going to be here x bar, y bar. But of course, it's not already the x here. It's going to be 4 units. I mean the y, 4 units from here to here. But there, unlike the other one, the first one, because the other one had some protruding which we couldn't able to create this line, this horizontal line from all. Now, our task is to get for the coordinate for the center of gravity. Of course, here we are going to be having weight acting here. The weight which is going to act here is W2. Now, the x coordinate from here up to here. Now, the x coordinate from here up to here, we need now to first get this one from here up to here. Using this idea from. So, if you want to get, you can get from here, but I want this one from AE. That's why I'm going now to get this one here. So, meaning to get this distance is always a third of the height. So, this one is a third of the height. So, the meaning, this one, if I a third of the height, my height is 12. Instead of a third of the height, it's going to give me 4 meters. So, meaning, here I have 4 meters. It means that now from here, from this line up to here, I'll add first of all the 10, then plus this 4. So that's why here I'm adding 14 as the coordinate. Now, from AB, from here up to here, you see this is 8. So the middle of this is going to be 4. As simple as that. Now, after getting that, this one now I'm adding the whole from there is 14 meters up to where that center is. You get the 10 plus the 4. From here, you need always to know that from the base, if it's from the vertex, it is 2h. If 2h over 3, from the base is 1 over 3. That is the height, as simple as that. So the rest now, we just substitute into our formula. So our x bar, y bar, is going to be now the weight 1 plus coordinates of that weight 1 plus weight 2 plus the coordinates of that weight 2, which we have already. All over this corresponding weights, we just add them. Now, of course, our center of mass is going to act there, and this is going to be our, what we added, 128 W. That's where it's going to act. Simple as that. So, you can do this now. Here I'm drawing so that I can explain, but you can do this in the example. So, this is the distance. What other people use tables. So, this is the distance from AE. This is the distance from AE of this. The y, the vertical distance from AB is 4 and 4. It means that even this is the line of symmetry. It means that now, and you see it's covering, there's no protruding sides here. It means that also this y coordinate is going to be for that one, I'm very sure. Anyway, let us just put in our values and we'll simplify. So our W1, the weight 1 was 80 W. The coordinate where this weight is, you see it's acting here because this is the center of mass of this. So the center of gravity of this, whereas where that weight is going to act. And the center there is 5, 4. So plus now 14, 4. Now what we are dividing with, now these weights. Okay, now I have to simplify these two up. We are going to be having my cow. Okay, pressing now this onto my cow. What I get is I'm getting this as 1072 W. Then now this is when I press the upper, then I press the down. It's giving me 5, 1, 2, W. Roll over the total I added is 2. I got 1, 2, 8 W. So from there, this is going to give us our x bar, y bar is going to give us, now we get this divided by that, 1472 W divided by 128 W, then 512 W divided by 128 W. That's what we are going to get there. And so this one is giving us so here I'm getting 4, then up, I'm getting 8.375. So therefore, my center of gravity is going to be at 8.375, 4. I think you see, because R4, well, this was the right of symmetry. So meaning that it's going to also be there, as simple as that. So that's how I handle it. Now, if you can ever get this from there, you don't need to draw this. All you need to is to just get your weight, multiply, and you get the coordinates. You can do it from there. So from the paper, you don't need to do this. This one I'm doing it for just explanations, but you can just get your weights and then put the coordinates. If you determine them properly, what people forget here is, after getting this distance from here to here, they forget to add. So they forget to add that from here up to there. That's why I'm getting that. And I'm adding. So after getting the 4, they just constant. Always get this distance from those two axes they are telling you from AE up where the center of gravity of this is. That's it. I wish you